Oke, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dear honorable judges and my beloved colleagues, according to World Health Organization 2025, cancer is the leading cause of death worldwide with nearly 10 million deaths. In 2022, 2.3 million women were diagnosed with breast cancer, resulting in 670,000 deaths worldwide. Currently, there are various alternative treatments for breast cancer, one of which is the use of DNA for gene therapy. However, the challenge in DNA-based therapy is in the delivery method, namely increasing DNA absorption into cells. Therefore, the development of more effective and efficient delivery method is needed to increase absorption and bioavailability, one of which is by developing DNA-carrying lipid molecules. As a pharmacy student involved in research, I see how health access and equality can be bridged through local scientific innovation. This is where the idea of converting avocado seed waste into high-value material for cancer therapy was born. This can support the realization of SDGs number 3, namely good health and well-being. Therefore, I'm Nadya Putri from Muhammadiyah University of Surakarta, proudly present avocado seed living nanoparticles, youth innovation for global health sustainability. Our main task is to create a self-efficient and natural-based DNA delivery system. Plasmid DNA as a gene therapy vector requires a carrier that can protect and deliver it into cancer cells. So the step we take involve a systematic scientific process. First, isolation and purification of PX459 and VM-stable plasmid DNA to ensure purify and target gene sequence verified through restriction, enzyme, and PCR. Second, formulation of lipid nanoparticle with avocado seed oil using the mini extruder method, producing nanometer-sized particle. Third, physical characterization using a particle size analyzer to ensure particle size, polydispersity index, and zeta potential meet biological standard. Fourth, in vitro testing was conducted to evaluate the ability of lipid nanoparticle to deliver DNA to breast cancer cell. As a research team leader, I was involved in methodology design, research analysis, and scientific publication in national media. We also developed a digital communication strategy through social media to educate the public about green biotechnology innovation. So this study found that the VM-stay gold and PX459 plasmid were successfully isolated under condition of 45 that met laboratory standard is optical density 690 per optical density 260 per 280 um, 1.816 until 1.636 for PMC gold and 1.972 until 2.099 for PX456. Okay, the plasmid digestion using EcoR1 SCH1 restriction enzyme, and PCR amplification produced fragment patterns consistent with theoretical prediction. PCR amplification of the plasmid produced a band approximately 722 base pair, which was consistent with in silico prediction, indicating successfully amplification of the target segment. Okay, this is the amplification using PCR and digest plasmid. The lipid nanoparticle production process successfully produced a nanoparticle dispersion with satisfactory particle size, polydispersity index, and zeta potential. And the last is in vitro transfection tests show successful expression of the PM state called plasmid transfer cancer with the help of lipofectamine. This proves the success of gene delivery process using this commercial lipid vector. Meanwhile, the process of plasmid delivery using lipid nanoparticle is still under development and future evaluation to determine the efficacy and stability of delivery system. Okay, as Hippocrates said, nature itself is the best physician. Nature provides valuable resource for human health. Therefore, I'm here to bring innovation by combining natural wisdom with modern technological advance as the medical of the future. So that concludes my presentation. Wassalamualaikum warahmatullahi wabarakatuh.